Agenda. In this short video, I'll discuss the following topics. Topic number 1, normal distribution, including standard normal distribution, concept and related formulas, Excel-related functions. Topic number 2, the difference between density function and cumulative density function, and related Excel functions. Topic number 3, one simple example or application. Topic number 4, exponential distribution. Next, we are going to look at standard normal density distribution and cumulative density distribution. Okay, the first one we generate x column. Okay, we start from -3 up to +3 with an incremental value 0.25. Okay, so we type -3, -2.75. Okay, the incremental value is 0.25. Okay, so we highlight, we copy and paste. Okay, so this is our x value. Okay, the next one is density. Okay, the density we are going to use standard normal. Okay, again, the standard normal, the mean is 0, standard deviation is 1. Okay, norm. Okay, dot s dot dist. Okay, so norm dot s dot dist. Dot s stand for standard normal. Okay, and the first value is x or z. Because we are interested in the probability density function, it will be the second one. Okay, so false. Okay, false. Okay, and I'm going to use show formula. Okay, equal show formula. I'm going to use show formula to show the formula of C4. Okay, C4. Okay, just make it a little bit bigger. Okay. Okay, so this is function we use to calculate density function for a standard normal distribution. Norm dot s dot dist. Why false? Because we calculate density. For the cumulative, it should be true. Okay, we copy and paste. Copy and paste. Okay, and so let's highlight. Okay, we insert recommended charts. Okay, so this is our density. So this is our density, and because it's stand normal, it's centered around 0. Okay, the distribution, the standard deviation is 1. So mean is 0 and stand again. So mean equals 0 and standard equals 1. So this is our standard normal. Okay. Okay, so let's look at cumulative. Okay, the cumulative, same thing, norm dot s dot dist. Okay, the only difference is it's cumulative, it's true. Okay, it's true. So let's copy and paste. Okay, and you see, because it's symmetric around 0. So when it's 0, so it's 50. So any value, any random number between negative infinity and 0 is 50%. Okay, and so let's draw. So we highlight x column, hit and keep Control key down and highlight cumulative, insert recommended charts, and okay, so this is standard. this is standard density distribution function graphs. So this is cumulative standard normal distribution. Next, we are going to generate 500 normal random number from a normal distribution. Suppose we assume mean is 3 and standard deviation is 0.5, for example, 3 and 0.5. Okay, then we generate random number, we calculate the mean, we calculate standard deviation, then we standardize these random numbers. Okay, and we click data, and we click data analysis on top right, and then we go to random number generation. Okay, random number generation, because we are interested in one column. So this is 1 and 500. Okay, and so this is standard normal. Okay, so this is normal, and the mean is 3, and so this is 0.5. Okay, 0.5. And if we want to generate the same random number, same set of random numbers, we use the same random seed. So we'll use 3, 3, 3, and out the range. So let's put it here. Okay, here, and click OK. So let's call them X. Okay, then we go to Control N. It's 501. Okay, then we can calculate mean and we calculate standard deviation. Okay, the mean equals average. So average. So X column. Remember, we start from 3. Okay, it should be roughly to 3, and STDEV. Okay, standard deviation. Okay, then it's A column. Okay, and you see the standard deviation should be 1. Sorry, standard deviation should be 0.5, and mean should be 3. Okay, roughly. Okay, and so this is so we call it Y. And so usually we standardize our data set. Okay, what do we mean standardize? Because the mean here is 2.9 and standard deviation is 0.559. Okay, and we want to generate another column with mean 0 and standard deviation is 1. Then we can easily use, we check the table of standard normal distribution table, or we use the corresponding value, and in the future we will going to conduct some hypothesis test. Usually we use the standard normal distribution. Okay, how to standardize is minus mean divided by standard deviation. Okay, so Y column equals, so this is X1 minus its mean. Okay, minus mean. Because we always minus the same mean, we have to hit F4 to lock it. Okay, standard deviation is 0.559. Again, we hit F4 to lock it. Okay, then we just copy and paste. Okay, copy and paste. So this is our standardized time series. Okay, so let's calculate mean again. So mean, this is average. So we use F column. Okay, so means 0. Let's look at standard deviation. So STDV. Okay, standard deviation of F column. Okay, then, so this is mean, this is 0, and this is 1. So let's look at the meaning of density function. Okay, so let's use standard normal. Okay, for the standard normal, we know it is like bell shape. Okay, so let's use standard. Okay, so stand is mean equals 0, and standard deviation equals 1. Okay, so actually the first thing is, so what is the meaning of probability density function? Okay, so this is density function. Okay, so let's randomly pick up a value x here. Okay, so let's call it x1. Okay, and what is so this height? So the height will be x1. Okay, and from x1, x2, and so we call delta. So this is delta. Okay, so fx times delta. So actually, so this is probability, and between x1 and x2. Okay, so actually if we draw two vertical line, so this area will be the probability, the random number between x1 and x2. Okay, between x1 and x2. Okay, and because so this is like cumulative. Okay, so let's look at 0. Okay, and suppose it's 0. Okay, and because the standard normal is symmetric, we know we have 50% chance less than 0. So this area, and so this should be 0.5. So this is 0.5. So this is called cumulative. So this is what is cumulative. Okay. So what is cumulative? Okay. So cumulative is simply probability. Sorry. This is probability less than equal to z value. So if we randomly give up one value or x value, so let's use x. Okay, we use x value, so it's called cumulative. Okay, and so this is so what is probability? It's less than or equal to 0, and we know it's 50%. It's 50%. Okay, and so let's look at if we grade. Okay, so let's use choose one value here. Suppose this is x2. Okay, so what is the probability? So what is probability is greater than x2? Okay, x2. Okay, and because we know the whole area under the density function is 1, so the complement of this part, I'm going to draw another one. Okay, so I draw another one, and suppose this is x2. Okay, and we draw a vertical line here. So this is cumulative. Okay, so probability greater than x2 equals 1 minus probability less than or equal x2. So actually this is definition of complement. So if we want to calculate the probability greater than a value, and we use 1 minus cumulative probability is less than this value. Okay, so this is number 3. Okay, the number 4 will be between. Okay, suppose we have two values. Suppose this is x1, so this is x2. Okay, we want to calculate probability between these two values. Okay, so this is we want to calculate probability between x1 to x2, and we know, so if we use the cumulative concept from negative infinity to x2, So this is cumulative up to x2. And same thing apply. So actually its probability is the probability is less than or equal to x2 minus probability and less than or equal to x1. Okay, x1. Then we have the probability between these two values. Okay, and again, cumulative we can use norm, and if we use standard s dot dist, so standard norm distribution, so this is x value, then we answer true. Okay, answer true. And because when we calculate cumulative, so this is the last input will be true. Okay, if we use general format, so equal norm, okay, dot dist, and then we enter x, and if this is 0 and 1 and 2, then these two are equivalent. So these two are equivalent. 1. Okay. So I put the density function, standard normal density function here. Okay. So we know actually the standard normal distribution is centered around 0 with 1 as standard deviation. Okay. And so if 0, what is probability below? So actually suppose x equals 0. So what is value below? So this is cumulative. So actually it's probability. Okay, so we use cumulative. Okay, norm s dist. Okay, so this is x value and z value. We answer true. Okay, so actually we got a value of 50%. So 50%. So if we choose a value of -2, what is corresponding value? So let's look at, okay, I'm going to use show formula. Now we can use show formula. Okay. We use norm dot s dot dist. The true means cumulative. Okay, and so we apply the same formula. So this is okay. So actually, so this area is about 2.275%. So this 2.5%. So what is the complement of this one? The complement actually is equals 1 minus this one. Okay, so 1 minus this one. Okay, I'm going to show the formula. Okay, so if we say what is the cumulative probability below -2, the answer is 2.275%. So what is the probability above -2? The answer is 97.725%. Okay. Another concept is it's a symmetric. Sorry, another concept is, for example, is inverse. Okay. Suppose we say, hey, what is 5%? So what is 5%? So we know the probability. Okay. So we know the probability is 5%. What is corresponding x value? Okay. So if we say, hey, this is 50%, we know this should be 0. Okay. So let's look at, okay, norm s inverse. Okay. This is inverse value. Okay. It's opposite of first one. So this is x. The probability, So we should get a 0. Okay. And suppose we have a negative 2. Okay. Sorry, we have this value. So we have this value. Okay. Then we should get a negative 2. Okay, so let's use show formula. So show formula 0. Okay. And then we should have, so this is negative 2. Okay, let's use show formula. Okay. We have two functions. One function is called norm.s.dist. For a given x value, we find probability. So this is the opposite of this first function. We are given the probability, we find corresponding x value. So another way to find it is, suppose, what is this value? Okay, so let's get this value. Okay, this value. Okay, this is negative 2, we should, so let's find it. We should get a positive 2. Okay, it's a positive 2. Let's look at one example. Okay, so this is in class exercise 27, repair cost. Okay, the average cost is $400 per repair. Okay. Assume the cost follow a normal distribution with a standard deviation of 80. Okay, so let's look at the 8. So what is probability that cost will be more than 450? Okay, so let's type some initial given values. So the mean and standard deviation. So the mean is 400 and standard deviation is 80. Okay, 400 for the mean and standard deviation 80. Okay, and for A, okay, for A, okay, so actually we have two methods. Okay, so let's look at the method 1. Okay, method 1, and so usually method 1, I standardize it. Okay, method 1, I standardize my value, then compare with the standard normal distribution. Okay, the first one is I calculate my z value and using minus mean divided by standard deviation. So my value is, okay, I forgot, enter 450. Okay, so this is 450. Put them together over here. Okay, so my z value will be 450 minus mean 400 divided by standard deviation is 80. I'm going to use show formula to show the formula of D6. Okay, it's bigger. Okay, so this is my value minus mean divided by standard deviation. Okay, first one, I calculate probability z is less than or equal to this value. Okay, I'm going to write value I calculate the value less than z, okay, less than z value. Okay, and we use norm s.dist because this is standard normal. Okay, so z value is 0.625, and so this is probability. So this is this is cumulative probability. So I answer 2. Okay, so this is, I'm going to use show formula. Again, so this is not direct answer question A. A is what's the cost greater than this number? I calculate probability is less than this value. Okay, so the probability greater than Z is complement of this one. So 1 minus this value. So after we got this value, then we have complement. We have complement. Okay, so this is I call the method 1. How about method 2? And method 2 is we simply use, again, I'm just going to, you can use one cell, and I prefer 2-step. Okay, the first one is we use norm dot dist. Okay, we don't use standard normal. Okay, so the first one is our value, 450. Second input will be our mean, and third input will be our standard deviation. Again, this is cumulative. It's true. Then we have the same result. So this make the red. Final answer will be 1 minus this value. Okay, then we have same result. Of course, you can just just equal, and so another one is simply 1 minus norm dist, just 1. Okay, so this is x value, mean value, standard deviation, and 2. Okay, again, we just one step. Okay, and the first part I'm going to show the formula. Okay, if you really understand the concept well, then you can use, so this is 1 minus, because the probability greater than 450 equals 1 minus probability less than equal to 450. Okay, so what is probability that cost will be less than 250? Then if you change this value, okay, so let's do it. Okay, so this is B. Again, there are two methods. Okay, we have two methods. So the method 1 will be we modify, we calculate it standard. Okay, so this is equal 250 minus mean divided by standard deviation. Okay, divided by standard deviation. So we have a negative value. Because 250 is less than 400, we have the negative value. And then equals, sorry, this is, we standardize. Okay, then we calculate, so this is show formula. So we standardize. Okay, then we calculate corresponding probability. Okay, so this is norm S dist. Okay, so Z value and 2. Okay, then we have like 3%. Okay, and B is only asked what is probability less than or equal to 250. The answer is about 3%. Okay, 3%. C, what is the probability between 250 and 450? So this is C. Okay, and C, and we know the first one. So actually, you see the 450 is this one, and 250 is this number. Okay, then actually we can get our result very quickly. Okay, so our result is, okay, the probability less than or equal to 250 minus probability less than or equal to 250. Sorry, 450 minus 250. Then the difference will be the probability between.
Shutterstock Music. Shutterstock Music. Shutterstock Music. Shutterstock Music.
Directly the method to apply Excel function. Okay, and so first one we type. So we only have one variable. It's called mean. Okay, the mean is 15. So loading time is 15. So average loading time is 15 minutes. Okay, and so this is method 1. Okay, and also I'm going to make it bigger. Okay, and I'm going to put it here. So E. So what is E? Okay, you see we have, so this is mu will be our mean, and X is 6. So this is X. 0 is 6. Okay, X is 6. So E is exponential 1. So this is our E value. Okay, so method 1, probability is take less than 6 minutes, less or equal to 6 minutes will be, so this is 1 minus E. The power is negative, so negative x0 minus mean. Okay, so this is first method. Okay, and again, the loading time on average is 15 minutes. And what is probability? Loading time is less than 6 minutes, less or equal to 6 minutes. The answer is 33%. So show formula. So we apply it directly. Okay, we apply the formula directly. And so let's look at the second method. Second method is exponential dist. Okay, the first one is x. The second one is 1 over mean. Okay, so this is x. This is 1 over mean. Okay, and then we answer true. Okay, I'm going to show the formula. Okay, show the formula. Okay, we have the same result. Okay, obviously this is a very bad design. Okay, and the first one is x, second one should mean instead 1 over mean. It's very bad design. I'm going to design a macro to correct this issue.